Welcome to Marine Engineering Hub. This is your narrator Ravi Gupta. Today we're gonna talk about Pilgrim Nut and one of the method of fitting the propeller onto the shaft. That is, one method is dry push-up method and second method is oil injection method. Today we will discuss about the dry push-up method. Okay, so and we will discuss in detail the construction and modification which have been done in the Pilgrim Nut over a period of time. So let's begin the video with the Pilgrim Nut. So the first question is that what is a Pilgrim Nut? So if anyone asks you about this thing, so you can say Pilgrim Nut is an attachment which hold propeller hub in place. The main purpose of Pilgrim Nut is to place propeller hub in its proper place onto the shaft so that it has good interference fit with the shaft. So what I mean to say is that in this diagram you can see this is the tail shaft, okay, and this is the propeller hub. That this is the propeller hub and this is the propeller blade. So as you can see, the propeller blade is been kept on its own place by a help of this nut, and this nut is called Pilgrim nut. Okay, so same thing I have written here. So once the propeller is fitted onto the shaft, to make sure that this propeller shaft and the propeller hub doesn't get loose, this Pilgrim nut is fitted, and therefore it ensures that the interference fit is maintained all through the lifetime of a ship. Now, Pilgrim nut is not only used for keeping the propeller in place, it also is used for detaching the propeller hub from the shaft. Both attachment and detachment are carried out by help of Pilgrim nut and by two methods. So what I mean to say is that here as you can see, this Pilgrim nut is not only keeping the shaft in place, it also been used to detach the whole thing like this. Okay, we will discuss it in a later part of the video. Okay, now the first method of attaching or detaching the propeller hub onto the shaft is the dry push-up method. This is the method which is been used in a earlier old ship. Nowadays we are using oil injection method, which is called wet method. Because what are the reason we will discuss later. First let's see what is dry push-up method. So dry push-up method is tail shaft and bore surface are to be dry and greased. So let me give you a basic diagram idea. As you can see, this is the shaft. Okay, this is the propeller boss and this is the Pilgrim nut. So first point which I am saying is what tail shaft and bore surface are to be dry and degreased. Okay, so to make sure that the surface preparation is to be good, what I mean to say, if the surface preparation to be good, there should not be too much of roughness and it should be degreased. Okay, means this surface where the propeller hub is going to sit on the shaft. Okay, after that, to determine the correct push-up table is provided by which correct hydraulic pressure is decided for the ambient temperature. The movement of propeller hub is checked by the dial gauge. So Second thing, first thing what I have told you, the surface preparation is priority and surface preparation is very important. Second, this hydraulic pilgrim nut will push the propeller hub onto the shaft to make sure that the propeller hub having good interference fit with the shaft. It need to be pushed in a particular distance onto the tail end shaft. As I've earlier also told you, by design, the propeller shaft is tapered, okay, so that it can have a good interference fit and a maximum point of contact. So, second, what I mean to say is the push up data is provided. What is push up data? You will get clear picture here. Is a data in which depending upon the ambient temperature outside, depending upon the ambient temperature outside, how much load you have to give, how much of hydraulic pressure you have to give so that it will travel a particular distance. So suppose you are in a temperature of 25, ambient temperature outside is 25, so you have to give 8852 kilonewton push up load, or in pressure you can say you have to give 56 megapascal to make the propeller hub move 17 mm of forward direction. So let me show you by diagram what I mean to say. Suppose you want to push the propeller in this direction, okay, in the forward direction. So by seeing the this table, you will get the temperature, you will get the load, and now you have to measure with the help of dial gauge, which will place here the push up distance. It should be 17 mm, but it is also like that 17 mm it has been written. It may happen it may move 16 or 15.5, so that is approx you will get an idea, okay, it has moved that much of distance. Now let's see what after that what you have to do. So what we have done, we have done the surface preparation, we have seen and checked that how much pressure we have to apply for a particular push up distance. Now the third thing is the pilgrim nut. Pilgrim nut has an internal nitrile rubber tube, which is when inflated, hydraulic force still loading against the hub. Loading should not come out one third of the ring width to avoid rupture of the rubber tube. So this is a very basic diagram which have been given in Mac George. As you can see here, this is the propeller boss. This is the okay shaft, tail end shaft. Now this is the pilgrim nut. You will get a clear picture here. What I mean is this. Okay, this is a pilgrim nut, this is a shaft, and this is the propeller boss. So what is happening in the pilgrim nut? A nitrile rubber tube is provided. Okay, this nitrile rubber tube is provided. It's like a tire. Means you have seen the car tire or truck tire. It's like that. Okay, and this is the steel loading ring. This is a steel ring which has been attached to the nitrile tire. Now the nitrile tire is been inflated by the hydraulic pressure. When this nitrile tire is been inflated by the hydraulic pressure, this loading ring will be pushed. Why? Because when the force is exerted on inflation, that will be transmitted to the loading ring and that will be transmitted to the propeller boss, and hence this will try to move the propeller boss onto the taper section of the tail shaft. Once more I will repeat to make the concept clear. The hydraulic pressure is being exerted from here to the nitrile tire. After while the hydraulic pressure is exerted on the nitrile tire, this pressure will be transmitted to the loading ring, and this will push the propeller boss. Okay. Now, as I've told you earlier, that pilgrim nut is used both for attachment and detachment purpose. In the top part, you can see that it is being used for attachment. You can see the nitrile tire loading. This is the steel part, loading ring, steel loading ring. When this thing is inflated, it is pushing the propeller boss. Now, in the lower diagram, as you can see, now this is the detachment method of the pilgrim nut. Means when we want to take out the propeller or propeller from the tail shaft, so we will pull out from this taper part. Means we want to take out the propeller boss, so we will pull it in this direction. And top part, you are seeing that we want to push the propeller onto the shaft, it is exerting this direction. And in lower part of diagram, you can see it is exerting in this direction. We want to take out the propeller boss. So here, as you can see here, this is the propeller boss. Okay, and this is the pilgrim nut. This is the pilgrim nut, and this is the tail shaft. So what we are doing, we have first what we have to do, we have to take out the pilgrim nut. We have to take out the pilgrim nut. We will take out this pilgrim nut. While taking out the pilgrim nut, the boss will not come out because the section is taper, so it will be on its place. After that, we will reverse the whole thing 180 degrees. See here, as you can see the angle is like this. We have taken it out, and now we will reverse it and we will fit it back. Okay, so as you can see, if you see, watch carefully, the loading ring direction is here. Now the loading direction is here. So I hope you got that we have taken it out and we have put it in a reverse direction. And on the reverse direction, on the propeller boss, this hexagon nut is fitted with a withdrawal plate. A withdrawal plate is provided. You will get a clear idea here. See what we are doing here. What we are doing, we are putting a hexagon nut. This is a withdrawal plate, or you can say strong back, and we have reversed the pilgrim nut, and the loading ring is faced in this direction. So what we are doing right now, we have fitted the hexagon nut. This is the withdrawal plate, and we have put an wooden block here, so that while we are taking out the propeller boss, it will not bang on the pilgrim nut. It will not give a shock to a pilgrim nut. So now again we will inflate the nitrile rubber. Again it will exert pressure on loading ring, and it will exert against the withdrawal plate. Okay, but while we are pushing it up, it is applying pressure against the propeller boss. But while withdrawing, it is applying pressure on the withdrawal plate, and hence as it is pushing it in this direction, the pressure will be transmitted from withdrawal plate to this hexagon nut and ultimately pulling the propeller boss out. Okay, see, we have reversed the thing, and the loading ring is exerting pressure on this withdrawal plate, and it pulling the whole thing out. Now, as you can see here, okay, I hope the thing is clear. Now let's go again to the dry push-up method. So in the push-up method, what I have told you earlier, that the surface to be prepared, the push-up from push-up table, you need to know the correct direction. Okay, now with the help of pilgrim nut, you will see how it's going to push it up. Check meeting surface by blue marking. The temperature between shaft and hub should be seen. Very important. So now you will first check the surface and then you will check with the help of push-up table. You will check that okay, what will be the pressure required for particular distance at particular temperature. Third, you will check the temperature between shaft and the propeller boss should be same. It should not be any pressure temperature difference. After that, we will start the dry push-up method. Mainly, if anyone asks you why it is called dry push-up, the thing is that in between the propeller boss and the shaft, there is no oil method or oil thing is involved. The whole thing of push-up is been done only and only by the pilgrim nut. Okay. Now the process is very simple. First, we will initially jack on the shaft tapper, initially loading 67 bar, and we will mark the reference mark 25 mm. Mark the reference 25 mm from the forward end of the hub, and this point is called 0 point. So what we are doing? We are first giving a first we'll put the propeller hub on its place, and after that we will tighten the pilgrim nut at a particular point and we'll give a initial loading of 67 bar. Okay, and we'll mark that after that a reference point. Mark a reference mark 25 mm from the forward end of the hub. Okay, so what we are showing, first what we will do, first we will mark a 25 mm here distance on the forward part of a propeller hub. So suppose this is the initial, this point is called 0 point. First we will put the propeller boss on its place, we will put the pilgrim nut, and the point where without applying any pressure, that point is called 0 point. And after that we will mark the push up length, means here we are taking push up length of 25 mm, so we will mark that on this here. Okay, and now we will apply the initial loading of 67 bar. So what we have seen, that suppose we are taking a reference that applying a 67 bar of load, the hub should move 25 mm. So we are making the first point. Now after that we will do one thing. We have marked the 25 mm. Now we have applied 67 bar pressure here. The propeller hub should move to the 25 mm. But what we suppose we observe that it doesn't move 25, it moves 20. No worry. After that we will do second push up. We will do second push up and we will mark from that 20 mm to again 25 mm forward, and we will do again second push up, and then we will mark that point. So see here, turn the nut when the loading again flush, then full pressure, dial gauge should show the movement. Okay, now see, mainly by the push up length and by the push up method we know that how much the propeller boss is moving forward by every point we are applying the hydraulic pressure. Means in this way first push up, in this way second push up, the propeller will move forward. How much forward length we need to move, we will know by the help of a push up diagram. And with the help of the push up diagram we can come to know that a particular length of a propeller boss, how much push up length is required to make sure that it will have a good interference fit. So what I mean to say, as I've told you, suppose in first push up the propeller hub move 20 mm. In second push up, it move again 20 mm. Now, by the push up length diagram or push up graph, we know that if the propeller hub move overall 40 mm, then it will have a good interference width and that is sufficient. If we require furthermore, we will refer the diagram and we can do it again. So that is the way the dry push up method is being followed to carry out the propeller fitting on the hub. But this method is been now obsolete, is no more follow mode, and oil injection method is followed because it is more easier, more quicker, and less viable to damage and less thing oil friction and elements are involved, which I will explain in my next video. So I hope you like the video. Please do subscribe and please do share. And if you want to know about keyed and keyless propeller, you can watch my whole series of propeller in the playlist. Please do subscribe, please do share, and please share in a WhatsApp and Facebook group so that our marine group personnel can know and can come to this platform. Thank you, friend. Have a good day. Bye.